Hello students, welcome to the digital learning of session 4 of unit groups of BSc 3rd Sem Mathematics. I am Dr. Shashikala. In this session 4, let us discuss about permutation group. Definition of the permutation group. Let S be the non-empty finite set. So, if it is 1 1 and on to of the mapping from F from S to S, then we can say that it is a permutation on S. So that means, remember that we are concentrating on the permutation. All possible the group we can consider for a S1, S2 and the S3. If we are considering S1, so 1, 2 elements are from the set S is 1, 2, 3. So first possible the finite set is 1, 2, 3 and 1, 2, 3. Next possible in the S2 we can consider as 1, 2, 3 and 1, 3, 2. It is changing of the second and the third row. So S3 again we can take the possible, the row can be interchanged or the column can be interchanged. So again possible the set is S3 is equal to 1, 2, 3 and 2, 3, 1. This is about the permutation group. Next is degree of the permutation. The number of elements in a finite set S is the degree of the permutation. So how many elements are there in the particular set? So then we can say that number of elements will be considered as a degree of the permutation. Nextly, to explain about the symmetric group. Let A be the set containing n elements, then the group of all the permutation of A is called the symmetric group of A on n elements. It is denoted by Sn. So if A containing n elements, then Sn containing the n factorial elements here. Example, if we are considering the set A as 1 and 2, then F1 is we can consider as a 1, 2, 1, 2. F2 is again 1, 2 and 2, 1. So like this, interchanging of the rows and the columns, F1 and F2 we got it. So number of n elements and possible n elements which is framed from the set A can be taken as a symmetric group. So then Sn is equal to F1 and F2 is called a symmetric group of the set A containing 2 elements here. 2 elements are 1 and 2. Next, properties of the permutation. So first property is we can take equality of two permutations. Two permutations f and g of degree n are said to be equal if f of a is equal to g of a for all a belongs to S, where S is a finite set of n distinct elements. If f is considered as 1, 2, 3, 4 and 2, 3, 4, 1 and g is 2, 4, 3, 1, 3, 1, 4, 2, you can observe number of elements are or degree of the two permutations what we have considered here as f of a and g of a, both are equal here. So therefore this type of permutation we can call it as a equality of the two permutations. Nextly, to go for identity permutation. If all the elements are mapped onto themselves, then mapping is called an identity mapping and is also called as the identity permutation. Identity mapping, or it is called as a identity permutation. So the example you can observe, in the first row 1, 2, 3 up to n, in the second row also we have a 1, 2, 3 up to the n. So the element is same here. So therefore this type of the permutation is called as the identity permutation. Nextly, to go for a product or composition of two permutations. This is an important one. The product of two permutations is the composition of two mapping. If f and g are two permutations on a set A, f from A to A and g from A to A, then g composition f from A to A, since f and g are both 1 1 and onto mapping. So both the functions has to be exist here, that is 1 1 and also the onto mapping. So therefore composition of g and f is also 1 1 and onto itself. This permutation g composition f is called the product of f and g. See, clearly with the example we'll be knowing how the composition of two permutations will be. If f is equal to 1 2 3 4 and 2 3 4 1 and g is 1 2 3 4 and 2 1 4 3, f composition g will be, see, f is written as this with the composition of g. So how composition of f and g is taken? See, very carefully you have to observe. In the f, 1 2 is there. So after the composition, what are the elements, what are the sets we have taken here? So take the second column. So it is in the first the set f, we have 1 and 2. So here it continues with the g set 2 with 1. So 1 2 2 1. So therefore under 1 we have to write it as a 1. So secondly 2 3. So in the RHS side, so 3 under 3 we have a 4. So therefore, so under 2 we have to write it as a 4. Similarly 3 4 continuation 4 3. So under the 3 we are writing as a 3. So 4 1 again. So under 1 we have a 2. So therefore 4 2. See, this is the about the composition of two permutation. Nextly, the inverse of permutations. Let f be a permutation of a degree n defined on the set S. Then interchanging the rows of f is called the inverse of f. Just we are interchanging the rows. So if we are taking the set 1 2 3 4, then f is taken as 1 2 3 4 and 1 3 2 4. Then f inverse becomes, so interchanging the rows, it becomes 1 3 2 4, and so the second row becomes the first row, then first row becomes the second row here. So this type becomes the inverse of f. So therefore f composition f inverse is equal to I, which is equal to f inverse composition f. Nextly, about the cyclic permutation. So a permutation is said to be cyclic if each element is mapped onto the next element and the last element is mapped onto the first element. So the example is f is equal to 1 2 3 4. So after 1, in the first row you can observe, after 1 we have a 2. That means in the second row we have to leave the 1, we have to start with the 2, then 3, then 4, then the first element as a 1. So this type we are writing for a cyclic permutation. Then by definition of the cyclic permutation, f is cyclic, it can be written as 1 2 3 4. Nextly is about the transposition. A cycle of length of 2 of the form AB is called the transposition. So that is AB is written as ABC with BAC and its cycle of the length is 3. Disjoint cycles. If two cycles do not having common elements, then they are said to be the disjoint cycles. See, so we are considering the two sets here. So that is firstly 2 3 4 is there, second one it is 5 6. There is no common elements in the first one and the second one. So we can say that it is a disjoint cycles. In the first cycle different elements, in the second cycle different elements are there, therefore it is a disjoint.